Alrighty, so for the first question, I just put the two equations. The first one was the biomolecular to reaction, or reactant molecule, sorry, there's two here. So we know that it's elementary and that the rate will have just both of those reactants there. For the second one, we have the slow equation and the fast equation. And for the slow one, we know the slow is the rate limiting step. So we're going to base our rate constant and rate formula, rate law, off of the slow one. So the rate law is just going to be these two together. And then since we have two of them, we put the two up here. And I figured out the equation by adding these two sides together and crossing out the duplicates. And from that, we realized that NO3 is the intermediate. And so setting up an experiment for this, I was thinking back to 1210 when we looked at different lights with the spectrometer. And I'm wondering if there's a way to set that up with some sort of, I don't know, machine or something, just to measure the light, because NO3 would have a specific UV index or UV spectrum range. And so from there you could see, okay, does this solution or does this concentration have this NO3 UV in it? And therefore it would be this equation versus this one, because this one doesn't have NO3 in it. It doesn't take the two steps. It's just one step. And so we could tell from there that the NO3 in this one would have to be this equation, and that would determine that is this one. So I looked it up, and it was saying spectrometer, and the NO3 is seen on the UV spectrum. So it'd have to be seen with some other type of thing. Anyway, as far as the logistics go, for something else, we could set up the experiment, and we could, because of the rate, we know that this involves these two different molecules. And so if we change the concentration of both of these and had one stay the same, we could tell whether increasing this impacted it at all, impacted the products, or if this one was just impacted, then we would know that if this increased and this stayed the same, we would know that whether or not it had an impact on the reaction or on the products, then we would know, or it had an impact on the rate, I guess, then we would know that it's whichever one it was. So if we set up a table and put the concentrations, we could set that up in order to determine that.